there is not time as it's still like three minutes left before I really start. Today I have saved some bugs. Turns out to do here, and to do this case is this the new API. But I'll wait a little while longer before I do anything about that. So just stick around, and if you have any questions that something you would like me to talk about in regards to the code or something, like explain something, please put that message in the chat, and I'll eventually see it, I guess. I don't think I'm not looking at that often, so might sometimes forget to look at that, even if you have questions. Okay, like 2 minutes left. And then I'll be starting. So priority for me is to have, like right now, is to like weed out the bugs. There are a bunch of them. After the API changes and stuff like that, I think like there is some stuff that I didn't quite finish with the arrays, and that's something I want to look at later. I don't know if I have time today, but I have an obvious bug that I need to fix, and I might also add some capabilities to the time to go. Right. So okay. What happened here is I have something like this. Call parameter type does not match function type. And this my small test thing here is like just doing this, and it's the anonymous structure that's causing an issue. And what happens is that I do create a temporary, and then I basically load that as a value and then send it here, but there is a queries happening that should be happening to that, and that one is not, like, it's not doing that the way it's expected to. And there's another problem as well, because or problem, that is like it should not need to do that. So we are here. What happens here is that you actually get a value, and this value might be an address or a real value. Now we don't need to do this. So instead, if it's indirect, that's good. And then we can basically take that, like we emit an alka for that particular thing, and then we do a store aligned with the BE value here. Let's do it. No, that's not one. So we have a lot of stores. Some of them are going out of fashion. So we have BE aligned, we have the destination. Okay, so let's use this one. So we have the context, we have the destination. That was the one we created just up there. And then, okay, so it's called context here. Just been changing that everywhere. So that's the destination. We have the value, right? And we have an alignment. And this is the alignment, and we put it in here. Now that one is fine. Okay, here's a direct queries, and in this case, we just want to add this value, so we lower the want to make an R value of the B value here, I guess. Yeah, we actually want to store that, but because if it's a Boolean, we want to do something else. So maybe we should just value I don't know. We had some store, like we had store B value to a destination. So what did the code look like before that? We have the value, right? And that might be a Boolean. This used to work, so let's see what I did for that particular thing. So here, no, for a section. Okay. So change context emit expression. We take the db value and it looks like this. B store value into what? Okay, yeah. No, I remember. Okay, so it's you can actually get this one. Sorry. Okay, of course. So in this case, you just use this LVM value store value emit store. No. Store. There is one where you take the B value and make it a. Here, this one. So take a value, create something for that. So it should be like a value store. So the difference here between this one and the other one is that this will create at this point here, this is like we're not, but if we are, then we have this one. We should flatten it. In this case, we want to make that value into queries. Maybe I just do this thing here for now. Always like we do a printf to do optimize flattened b value. Okay, so now we have the value. That means actually that we can do we can take this one, whatever that one was. It is a we want the alignment. We don't need that. Maybe we don't need the careers. So it sort of depends. If it's if like the B value, if it is kind is a. Oh right, we should do something else as well. So, but that's something that's beside the point. Okay, so we want to do a. There is one more thing in here. It can be a failable, and there's a way to make that one sort of emit itself. So let's see here. If it's available, okay, mid identifier, it might be available. Okay, so I think we need to do that. Two kinds. So B value might be value is adder, right? That's one part. In the case, we made cost of the value. But before that happens, we're going to put a store anyway. So okay, so we're going to do a bit cost of that one to the pointer type, which is the type that we want to queries to. Yes. So we want to queries to the type. Now we taking this that one, and we can basically do, now we can do a load here. So we can okay, no, we have that one. Everything is fine, we have the cost is set. Okay. Otherwise, we need to emit a holder for this. So we are going to, again, we are taking the maximum of these. Okay, maybe like if the alignment is too small for the regular way of loading that, maybe we should do, like if it's an address and like the alignment sign target alignment is type. So if we want to go like if we are loading something with greater alignment than what we have as an address, that we need to handle that. So than what we have, we cannot copy. So like if the hang on, this is the param type. Yeah, so actually it's in the B type. B value like the alignment won't matter, right? Because it's just a value at this point. That would only matter in the opposite way. So basically, if this alignment, which will always be set, right? So if it's an address, okay, we can do different things. So if the BE value alignment is less than the target alignment. Okay, so in that case, we need to do a copy instead. So let's do that. So if, wait, we have to do that separately. So in the case, we cannot directly copy. We instead want to, maybe we can do a bit cost. I don't know. Well, we're going to do these later on. I don't know if that's possible, if the alignment is different. Okay, I think this is a safe thing. The alignment is less, then we do a LVM value or value, like context. BE value. So this will basically lower it. So lower, load it instead. In this case, we have something nicely aligned. So you just do a cost. All right. And now we also know like the, so we have the maximum of the BE value alignment and the, okay, so maybe, oh, there's a bit field, so the alignment is a bit field. That's bad. Okay, maybe you do something like this on the side. All right, so, okay. So if we can direct the load instead, in this case, we have something like similar, we just do the cost, otherwise, else, we create a temporary. So we had that, I think, somewhere. Like LVM Metallica, and we want to have that context and the type, which is the type to queries to, and the name. So now the cost, I guess, is this one. No, we're just using the type. Damn it. Okay. So why isn't it happy about that one? Is the type? Oh, it is a. It is a type. It might be something weird. So I need to build this one on myself. So we're just going to do Metallica. I guess what is that doing? It's just using a type. So okay, we're fine here. So we're going to do that alignment, which is something we already calculated with it, which is target alignment. Or max alignment maybe. And then we are going to do an LVM store, a value store into that one, but we need bit cost to do that before. So we do a bit cost of this cost thing to the param type. So what do we have here? It's not quite correct that we have this, right? So, okay, anyway, we do the cost. This is the one. Both of these are now the same type. It's the type, the pointer type to this type. And we do a bit cost to get pointer type. So a pointer to that parameter. Now this is so this is the target we want to copy to. we do a store b value, and we do that using whatever b we have. No, sorry, this is now a value, right? So we are taking the context, we are taking the target, we are taking the value, which is a value, and we will put that using its alignment, which will be the max alignment, because that's what we used. So now the target is containing the result. No, sorry, the cost is containing the result. So now we have whatever value it is, we have that in cost. And then we can do the gap into that. Wait. Why do we build that one as a temporary? That seems slightly insane. Because we should only need, okay, we have to query it to something else. Yeah, that makes sense. Sorry. So in the value, it's in the cost, and we are in cost some way. We have to do cost, so the actuals all the time. Okay. We could also do a load, but that would be less efficient. So now we have this result of everything, and it will always be the same thing, and it could be in different parts here. So we are going to, I think we only do this when we have multiple elements of the thing, right? So if you have a pair, we go here. So we get this, the temp is the cost, right? And so we load aligned this element, and we do that with this alignment, and then we're done for that. Maybe. Okay, let's see what happens. I made some, okay, here's something else. Okay, so because I changed that, now suddenly these doesn't work. And we remember that what we can do is just restore that one, because we don't quite need to handle these right now. So that would be a LVM store value something store. It returns a type emit store. Yeah. So this one is okay. And then we have the emit, not emit store. Emit something with store. Store something something. This one. Like, this is the downside of having a lot of functions, convenient functions, because you eventually forget about what does each of those do. And we see here there's a lot of to-dos here. This file is really something we should continue working on. Now I still forgot, there's still an error, but I forgot to do something. So to do, so here, load. Same thing here. Okay, what happens now? We do a load of test. And we use that one to cost whatever. But that's incorrect. So we have we do the direct queries. We have the value. We set the cost, and I think we do use the wrong thing here. So we should be using cost. That has the right type. Queries type, right? Okay, let's. It turns out that Sea Lion really doesn't like handling macros. And that's actually a valuable input because there are reasons for that. This implicit capture everywhere. So, okay. Call parameters. Let's look at what we have. It's not the create. Yeah, it is the creator. Sorry. So here, let's just compile that part because we do like this. So then we go to create. Oh, I think we have optimizations on. No, we don't. I got the mem set anyway. Okay, okay, we have that one. We want to call blur again. Okay, so we do a bit cost. What happens here? Let's just check that it actually enters this code. Okay, so go here, go here. Wait a minute. If there's not a queries type, or what? Wait, or queries type equals this. Now, let's see. That should work much better. Ooh, it worked. I'm not super surprised. What it did was I just assumed that everything was going to work out. So let's see that it does. What do you think it should do? So it's going to put the test into things. So it will load that one. We store it into temp queries. We do a bit cost to I32. But does it need to do that? Let me see what happens step by step. So we go in here. Now we have a we get the queries type. We know oh wait. If we shouldn't flatten the b value, then we go in here. So we haven't optimized this. That explains why it wasn't particularly optimized. Okay, so in this case, we do this gen commit value to be queries, right? And now look at this, we do that. Okay, let's see where this one is used. So it's used for the return API and elsewhere. So let's fix that. So the value is here. So it should be a v value later on. Let's go back and see where that's defined. Okay, b value. Right. Now this looks better. We take the b value, which can be an address then. So go in here. Like maybe it's smaller. Right? If we actually what we're doing, like this whole thing. So maybe it's basically, I think we still need to, we will still use this. and base is going to have in this one. Okay, so we have the value, we can call that b value, and we have the queries type, and we change that to be like queries type, right, like that, cancel type. Okay. So maybe we want to load, we want to cost, and then we want to store. And then when we're done, we are loading that, whatever that is. So here we get a bit cost. In this cost, like we get the original type of B type. And we store that one, aligned, and then we do, so we're going to finally load this one. And we use the max line, which is the one we used. Okay. So that should be it. So let's see where else it's used. So right there. And then under return ABI, now we don't have a return value. The return value is here. Like you made the return value, the return value is given there. So in this case, we can do it quickly by doing like we create the b value wrapper, and then we set that from value set, so value set, and we take this b value, we put the actual return value inside of that, and we take the actual return type, and then we can return the, take this BE value, put that one, so return. And now I want to change this one. Queries. That's much much briefer. And I think that is enough for that to work. I can remove this one because that's already done. And running that. Let's see here how that looks like. So what happens here? We are getting the coerced value. We bitcast that one to a literal. We load it, and then we call everything with that value. It is a bit sad that we need to do this. Hang on, this is something else. Sorry. And that we have to do this part, but I think that will be, it will be like basically a no op here. And Then we do something else and get stuff back. So let's see what it does. So the blorg doesn't do anything, but this one will return a test, and then that means we do again, we take, this is going to be like an I32. So we are taking that literal, sorry, we're taking the literal, setting it everything to 0, loading that one as a value apparently, then we do a bit cost. That seems like a bad idea. So this is unnecessary actually. And then we do a bit cost, we store it, pull it out, and then we return that. So we have some optimizations we need to do here for that one. So let's look at the literal. Something like literal. Okay, so here we emit initializer list expression adder, right? And then we do a load on that one. This is stuff that needs to have some optimizations later on. Because later it's we use this one, and then we want to we emit this one as an expression. So that's an address as far as we get there. Let's see what happens to that. So get here, this is not the return thing, I think. See here, yeah, this is just the normal one. But when we get to the return statement, we are doing this, right? And this is sort of bad. Although we are fine here, we want to pop, like, the error here is something we want to keep. So we don't want to pop we want to make sure that the error is lowered here, up here. So what we want to do is basically LVM value adder. So fold failable. So we want to make sure that it's maybe a value, or no, doesn't have to be an error, but we want to fold the failables in case there is one. So let's call that one like LVM value fold failable, and now it's no longer a static inline. We want to use that one. It's useful. We can take control over when the failable is folded. So what we're going to do now here is fold failable on this value, right? So we have a B value up here. So that is the actual ret value now. We remove that one completely. So the B value here is empty, completely empty. That means it's, I think it's like false to a value, right? So we do this, and if we are here, we can, what we do is basically we do a LVM store, like we store to whatever the return out is, and it's just okay. So we LVM store BE value, and we take destination, which is the return out, and we take whatever we have, like the ret value, sorry, we have like guess value, yes, going to do return value, something maybe, okay. And then we have the alignment. Now the alignment is going to be like whatever the alignment was of the return out, I guess. So the return out is going to be have default alignment. That means I just pass in 0 here, and I think that should use the default alignment of whatever we have. So I forgot the context. So the return value is like that. Now we're done with that. And then if we, like, the return value is doesn't have a type, that's a good indicator that is 0. But let's say it's like we have something else to say enough for that. So like if it's, let's use this one. Have like has return value, right? So has, if it has a return value, do this, blah blah blah. Now again, if it has return value, it doesn't have return value. Sorry. Otherwise, we want to return the ABI thing, and it's going to take like a p value. So that one is now not taking that, it's taking this. So we send that one, the ret value up there, into the result. Otherwise we take null and everything is fine. And so in this case we want to, if it's available, we have a return value, we do a store into actually there, I think there's an alignment, that a possible alignment here. So we have an info, it has a possible alignment. If it's a return value, this is, hang on, if it's available and we have a return value, in that case we take the return value, store it, and see return out. Yeah, so we still keep like a somewhere where we store the return value. And since you can't align that, it's going to be fine to do it like this. So here, and then we have the alignment, which is naturally aligned. Now this is a problem here. I see we should change this one as well. I was expecting that. So let's say this is a b value as well. So now we're breaking that return ABI thing again. Okay, so we get here, and then we can swap the ones. Doesn't really matter. We don't need to. If it's indirect, we have an alignment. So we want to store that aligned to whatever the return out is, right? So if there's a realignment, we want to use that. So we do the indirect realignment on the store because we have return out and we store a 0 here, right? Because there's nothing. Okay, because we just need to put this one and possibly a realignment value there. And then we have the normal return. In this case, it's pretty simple. We just do the store value. So we do a store or value store of this one. And then we have finally we have to query something. In this case, we already have a b value actually. So again, we can use the return value. It's going to be fine. We don't need to do that. Everything just works here. Okay. Now it's going to break it in a few places here. Here we get the failable by creating a null. Now we are fine with that, yeah. So it's a b, a value, like the value here. And we do a store of that. We do a store of the value. It's like set a value. We take this one and put or maybe we don't even need to do that. So if we have this, if it's available, in that case we need to do this part. If it's not available, then we just LVM emit return API context null, right? And in that case, we will always, with a null, we won't do anything, and we will end up having everything being null. So it will emit, oh, wait. Did it say emit ABI? Yeah, it did. So in this case, it should just be null. We are returning something implicit. We don't have emit return. And because now we don't have anything, let's just go with it. Right? We're done. Otherwise, we have a b value. We set that one to 0. Okay, type error. Okay, like that. And then we do an emit on that particular value, taking the reference of that one. Maybe we just do this. It's like the safest way. And then we have this one that is doing, the emit on error load. We don't need that. We can take our error out. Our error out is now always an address, so we can use that. We have a b value, LEM set address. We take the value, we take the error out, we take the type, which is a type error. So now we have just value. And again, here with something similar. So I just borrow this code here. So we have error war instead. And again, we take this. However, okay, yeah, that has to be true. Okay, and then let's see what happens now. Let's see if we see some, yeah, I think we see some improvement here. So we don't need this one. We don't need this load store here. We just basically take the test, queries it to an i32, load it, we're done. So that saved a load in the store here. I know that LVM will, remove this anyway, but it's nice to get like really tight and clean code. One thing is that it speeds up, of course, LVM's work when it has less to need to analyze. But also when you sort of want to read this later on, it's like it's a pain when there's a lot of stuff in there. Okay, so I think I need to do the testing thing. So let's just run the tests here. And so this passes for now. And now I will add something that actually, let's add to the tests where they are up here. So we have something like the, we add a new one, a new file directory called ABI. Okay. And the reason for that is that we need to what was this for this? Literal load. Okay, and I almost forgot what it looked like. It's going to look like this later on. So after this, it's going to expect something. So it's going to expect a literal load later on. And let's take this part which we had that actually did this a bit. So literal load is there, and it's going to, let's say we expect something like that, which won't happen, but it will give us the output here as an error. Yeah, here it is. So basically, I think this is like what we want. So I'm just going to take this and then just put it here as the test to make sure that it doesn't change. And now we have another test, 96 tests. And what we need to add now is getting a bit late, so let me see if I have some questions. No questions so far, okay. Is that I want to pass in the what I'm using for architecture. So here, let's see what the test sources are. No, sorry, that's going to be something else here. Test suite, and where is the Python code for that? this. Okay, so just happens to end up here. This is something that should be cleaned up as well, but right, okay, so now it's here. Okay, so we have this, and we start loading things, and we have a few things that we can, use as arguments and stuff like that. We have the args, the other args, whatever those are. Here, directives expect something something. So we need another one, which is called like if line starts with target, and then basically say that self, maybe not current file, reset defined. Okay, so self arc. Oh, one's empty. Oh, it's none, right? So in case there is something like that, so in that case arc is line 5 strip, no, not 5, it's 1 2 3 4 5 6, 1 2 3 4 5. Okay, so 6 7, and then we set that. Okay, so we're done there, right? So that's the header directive. And in time, when we compile, we have all the args, right? Where are the args generated? Compile. No args. Okay. So if self arc, then we have the args theory like this. If self arc, then args equals self arc. Maybe just put that in compile, because shouldn't this like be for everything, right? So if self arc, in that case args, no, those are the args, sorry. So if it's self arc, then we maybe have like equals self arc, then target is this. If self arc, then target is target equals plus self arc, right? So after here we can do the target something like that, I think. It's been a while since I did the Python. Yeah. So let's say I just write something bad here. Then we shouldn't pass in that one test. No, we didn't write that. Sorry. So we need to do like arc, target x86 Darwin, for example, x64 Darwin. Okay, what happens now? Cannot process the unknown option target equals. Yeah, so it's not so it's like this. So that passes. It actually cares about the architecture now. Let me just push this to dev, I think. So here we're just going to write, okay, what are the changes? Optimize BE optimize load of return some parameter types and also fix issue with non-expanding queries. And okay, so we have a bunch of them here. So I also changed the name somewhat here. It's actually not doing anything new. So this was the change we did. And then we also added the support for arcs. Add support for a specific ArcOS in tests. So that's an important thing, a step going forward. Let me just push this, and if it looks good on when processing this on dev, then we are fine. Let's see. So dev. Just now I'm just looking at the results here in GitHub. So it's doing spell. Downloading LLVM. And there it compiles, and is it done building? 6 seconds, 7, 8, 9. Yeah. So that looked fine, and then we are going to pull that one into main. Alright. So that one's done. We go back to master and check out the changes. We can now remove dev. Okay, that was it. We fixed the bugs, did some optimization, and that's it. Thanks for today.